today's problem is based on the sliding window, which is a subarray with k different integers. Let's go to the problem. It's super easy. It's based on what the concept we are using. So let's start with the problem. I will be explaining brute force, the time complexity, optimal approach, and time complexity. Everything I will be covering in this problem. So let's just sit and focus on the whatever I'm saying. Just focus on it. All right. Subarray with k different integers. Given an integer array nums and an integer k, return the number of a good subarrays of a nums. A good subarray is an array where the number of different integer in that array is exactly k. Okay, good subarrays. They are asking like if you have to count the number of subarrays where each number should be each distinct number should be exactly k. So this given as 1 2 1 2 3. So like you will see there are 7 subarrays are created. So 1 2 2 1 1 2 1 2 2 2 3. Okay, okay, this 1 2 1 2 1 2 1 2 and 1 2 1 2 1. Okay, so let's start with the brute force approach. I hope screen would be visible. So what we can do that, like this can we use two for loop and like store the element in my hash set and check if hash set size is greater than k, is equal to k. So I will just increment my count and else decrement. So what's my approach? I will be using for loop, which would be starting from 0 and which would be go to n, right? All right. So and here I will declare hash set. Sorry for handwriting. I am not using my mouse, so yeah. So for the next for loop, I will be using j, which would be starting from I, and it will be also moved to n. Okay, and what we can do, set in my hash set, I will be add set dot add nums of j. I'm writing a pseudo code. Later we will do a actual code too. If I add that, okay, okay. So I have added that in my array, set. I will check if, sorry, if set dot size is greater than is similar to k, is similar to k. So I will just increment my count co plus plus. Okay, else if my sets count is my set size is greater than k, so I will just break it and just shift my window, and at the end I can return k, and I will return co. So this is the brute force approach. Let's code it. So what I said I will be using, let's talk about first time complexity. As we are using two loops, so this would be taking as big O of n square time complexity, right? Let's just write a code for it. Int I is equal to 0, I is equal to nums dot length I plus plus Here I would be specifying hash set, which would be storing a integer. Set is equal to new hash set, right? And for the another loop of j would be starting from I, and j move toward nums dot length j plus plus, and set dot, I will be adding my nums in my nums of j in my set. Okay, I will be check if set dot size is similar to k. So what we will be doing, I will be incrementing the count variable. uh, Count is equal to 0. Okay, else if set dot size is greater than k, I would be making a break, and here we'll be returning count. So this entire code would take a big of n square time complexity, which is a quite huge. So but if this is accepted, but if I submit, it will give me a TLE. So how we can make this code better? By using sliding window, as they have specified the sub array, so we can use a sliding window over here. So what we were doing in our traditional sliding window problem, we will be keeping left pointer, and left would be 0, and my right would be just traversing over the array, right? And I will keep a hash map incrementing the value inside it. So I will be adding. So suppose if 1 2 1 2 and 3, so I will be 1, I will be keeping 2 in my hash map. So this would be appear once, 1 times 2 would be appear twice. So suppose 3 is come, so I my it is also appear twice, so my hash map will just decrement this value to 1, and this is how it would check like my hash map has a hash map has a k size or not. If it does not, if it exceed the k size, it's shrink down the window. Okay, like let's 1 2 1 2 3. So my hash map, first my right would be pointing to 1, so it would be store 1 2 at 1. So 1 again come, it would be make from 1, it would be become 2. 2 again come, it would become 2. If 3 comes, so 3 comes, right? So we have to decrement the value. We'll decrement this to 1. After that, we'll check it again. If we move forward, 3 comes, so it again make our hash map size 3. So we only want k is equal to 2, so we will again decrement, we will again shrink our left value. So it left become 1, 2 becomes 1. So my left come here. So uh, but if I put 3 again, it map size become 3, right? We want map size to 2, so we'll just remove this and make it as 0 1. So now it's become 0, so we will just remove it from our map and make add a 3 and its count. This is how we solve. And but here's the trick, one trick we have to use, like uh, can we find out the at most element They have asked us to find the element which is k different size, k different integer need to have. Can we find at most k different integer, at most k, or we will find at most k minus 1. Okay, and we will subtract them, so we will uh, get our answer. So let's dive into the code. You will understand it by writing some code out of it. So let's okay, so what I was saying, we will be keeping hash map. It would be storing integer and integer, and map is equal to new hash map. Again, we will be using for loop. It would be int right I is equal to 0, right is equal to nums dot length, right plus plus. Okay, and int will keep left pointer. Okay, uh, if right map dot put nums of right, and map dot get or default nums of right 0 plus 1. Okay, we'll keep this. I will be check I will be using while loop. If my map dot size it exceed the k value, so we will be checking if map dot get nums of left, if it's equal to 0, nums dot if it's equal to 0. So what we were doing, map dot put map, we will be removing it from map nums of left l, and here also map dot put nums of left map dot get nums of left minus 1. Okay, as we will be removing, and here we will just increment our left value, and we'll keep a count variable over here. Count is equal to 0, and that count will be doing count is equal to count would be added right minus left plus 1, and will be returning the count. So as I was saying, we have to find out for the left at most k element, right? So we'll be using a separate function which would be int solve, and here we will be similar, we'll be keeping nums and int k. Okay, and all this logic I will be adding in my solve function. Oh, control Z, control C. uh, in my solve function, and here what we can do, I will be at most value, so I will be solve of nums at most k, and minus solve nums nums k minus 1. So this is the question nums map, oh, sorry. After writing code, you should analyze the code line by line. So yeah, mm, let's check. Oh, it's got accepted. Let's talk about the time complexity. So it would be only as we are traversing over the array only using for loop once. So it would be taking a big of n time complexity and space complexity as big of 1. So yeah, that's all for the video. This was a quite challenging problem. You should try to solve this by all yourself. So we'll meet in the next video with the exciting problems. So yeah, thank you for watching the video. See you next. Like, share, comment, subscribe. Bye.